Last thing. Last thing. In this range, right in here. Okay? The question Ian posed was, where is there an easy way to find the half equivalence? Now, the first problem is this. With this pH, if it's strong acid, strong base, it's going to neutralize exactly at 7. Go ahead, it's all right. She'll just be on camera for a while.
Oh, yeah.
There we go. All right. Now, watching. If I do strong acid, strong base, this is going to hit right at 7. Okay? And you're going to notice that this isn't going to change significantly as we go. All right? Now, next piece. If, on the other hand, this were a weak acid. Okay? Think about that for a second. Some weak acid, let's say it's acetic acid. Okay, so AC is going to be the acetate ion. Now, this is what I would do on, say, a test, is say, okay, I'm going to use an abbreviation. AC is the acetate ion, which I know to be C2H3O2 minus. There. Now, anytime I write HAC, I'm covered. Right? Because I've told you what that is. Now I can use it freely. Okay? Now, so HAC is going to react with hydroxide. We're going to keep going until we've got O's and acetate ions. Right? Now, when I reach this point, I've run out of this. Yes?
Mm-hmm. Yeah.
Okay, so let's look for a moment at this point right here. Right before it jumps. What's in the beaker?
A tiny bit of HAC.
Okay, let's say we're right before it jumps, so there's no Ha's.
A lot of A-.
I got O's,
Yeah.
and I got water. It's all that's in there, right?
Yes.
You okay with that? Now, here's the trick. The reason this isn't going to be at 7 is because there are O's in there. A is the conjugate to a weak acid, right? So if you just put some O's in water, what do they do? What's this? Remember? It takes an H. Takes an H from the water, just like we showed 2 days ago when I used, was it Nadja and Jessica? Okay? It made Ha and OH minus. So let's think about that logically. If this is a weak acid, when you're done, you've got O's, but those O's are going to make a few Ha's and hydroxides, so where's the pH going to be? Higher or lower than 7?
Higher.
Slightly higher than 7. All right, so it's going to come into someplace in this range. It's not going to be right at 7. If it's weak acid, it's not going to be right at 7. It's a weak acid, it's going to be slightly higher than 7. Okay? If we do the reverse and we titrate a base with an acid, and it's a weak base, it's going to be slightly lower than 7 because what's left over is the conjugate acid of a weak base, so therefore it's going to be able to change over, not even.
If it's a weak acid and a weak base.
Well, you don't do that.
Okay.
Now, I'll tell you why. Because the whole purpose of titration is to figure out concentrations of different things. If you use weak, then they're both in equilibrium. And that would be, then you don't know what the heck's going on. A whole lot of math that you don't want to do. All right? So you either go weak acid titrated with a strong base, weak base titrated with a strong acid, or strong. Okay? Now, to answer your question, Ian, when I hit this point, and there are a couple of ways to figure this point. All right? When I hit that point, let me do this first. When I hit that point, let's say that is 48 milliliters of base acid. Where were you when you were halfway? 24. That's it. That's all there is to it, is you just go, okay, it's half the volume. Now, I'll tell you a little secret. If I'm going to be titrating on Monday and I really want that point, what I'm going to do is I'm going to do 2 runs. The first run, I'm just going to quickly figure out about where this is. I'm not going to write down any data. I'm not going to do anything. If I'm in my vinegar factory, I'm just going to go in and go, okay, it's about this. Right? Now, Then the second time, I'm going to take the same amount of acid, and what I'm going to do is this. I'm going to take data something like this. I'm going to take 1 or 2 points till I get close to where I know the half titration is. Then I'm going to take a bunch of points. Then what I'm going to do is I can speed back up till I get close to my equivalence point, and then I'm going to take a bunch of points. By bunch of points, I mean I'm adding a small amount of base here, larger amount of base here, small amount of base here, going up by only a few tenths. Because if I go a few tenths and I've got to add, say, 50 mils of base, and I go up by a tenth every time, I'll be there till next Tuesday.
But
right?
So you just want to do smaller intervals when you get close to the known point
To
of
the
accuracy.
to the two important points.
Yeah.
The two important points are the exact equivalence point and the half equivalence point. So those are where you take your time. Because literally, I've seen people sit there and they're adding like 2 tenths all freaking period, and they get 1 titration done. First one is slam it, get it pretty close. Second one is slow down here and here. Then do 1 more like that, and you should be able to get a really accurate graph in minutes. Okay? Now, questions? Okay, last thing. How do you actually do this? There's a couple of ways to find it. Old school. Literally, I kid you not. We would take a paper graph, we would draw a circle, a best fit circle of this curve, a best fit circle of this curve, and draw a line between the 2 midpoints.
Wow.
That was the equivalence point.
That's fresh.
And it worked really well.
Let's do it. Good thing we have calculators.
Yeah, good thing you have calculators. Now, what I said to you guys is, if you can think about it, this is changing slopes, is it not?
Yeah.
Okay? This is going from one slope to another slope. We can find the point of inflection. In fact, you can graph the point of inflection, and it'll give you a neat little peak right there where it's supposed to be. Okay? If that bugs you, there's a couple other ways that I can show you. But the simplest way, another way they do is they'll draw a line. It goes right through this. Okay? And then find the midpoint of the 2 points where it meets. There's a bunch of different ways. I'll bring those up for another day.
We're using calculator.
Okay, question on anything you've just heard?
Can we get a notice real quick?
Anything else?
Why?
Okay, go ahead. Ending titles.
Don't forget to like, smash the subscribe button. Weird outro music. See you next time on the Dr. Rippy.
No, it's odds and
show.
ends.
Let's get this suit